Right, morning guys. Can you all type your names for the register? And you've got a couple of minutes just to try and finish off this question from yesterday while I do the register. Cool. Let's wait for this to load. Cool. Right, so we've got Billy and Becky, Lucy, and George, and Scott, and Harry, Jay, Chloe, Danny, Elliot, Guy, Nula, Louis, Tristan, and Jake. Okay, so we are missing Callum and Ollie from what I can see. Okay, cool. Right, yeah, so as I said, we're kind of starting with the one we finished with yesterday, which is this one, so kind of combining transformations including modulus and translations. Right, so I'm going to start the Google, not the Google Classroom, I'm going to start the Microsoft Teams chat with you guys again, and could you send me photos of however far you've got on this one? So I'll start that call now. There we go. Right, so I'm joining that room now, so you guys should get an invite in a second to the Microsoft Teams chat. Cool, everyone should be invited. Alright, so yeah, if you guys could send me photos of your workings for this one, and then we'll start going through it. So I'll give you 1 minute just to get those uploaded. Because you should have had enough time to do this question now. So 1 minute. Starting now. Right, I suppose I do. I would like to see everybody sending their work for the rest of the questions today, though. Yeah, we'll start going through another. So look like some good suggestions there as well. The tricky bit with these ones is that we've got a +5 and a modulus. And yeah, you can follow bid mass, but you can also kind of do it kind of logically. So you've got, if we've got a function here, and then we apply modulus to it, well, we could just modulus that function. Then we can treat this +5 as happening afterwards because it's kind of outside the modulus. And yeah, you can look at that in terms of bid mass as well. But yeah, so we're going to modulus it first, and then move it up 5. So I'm going to draw both of these in 2 stages. So stage 1, modulus it. So this bit will look the same. Then we're going to get that goes up there, and that's going to look like that. That's going to go at 2, so it needs to be a bit higher than the maximum. So that point there would be 2, and that point there is still -1. 1. Then we need to move the whole thing up by 5. So at 5, if I put 5 here, that will be where our kind of sharp ends of this curve are. The bit that was at 2 is now going to be at 7, so the asymptote is now at 7. And the kind of bump was at 1, it's now going to be at 6. So -1, 6. Cool, right, let's have a quick check through and see how you guys did. So I think who posted first? I think it was Louis actually. No, that was yesterday. Or Monday even. That's first today. Okay, George. Yep, George, spot on. That looks good to me. Excellent. Who's next? Louis. Oops, sorry, Louis, I did your smiley face there. I didn't mean to do that. Can't get yours to open actually, Louis. That's weird. I'm going to try my phone instead. Where's that? There we go, it's opening now. But it's upside down. Yeah, I would. You ought to for Louis' one. Then you ought to label the asymptote and the minimum, those where the sharp bits were. Harry, good. Label your asymptote though and number that. Nula, I think you've done your order wrong there. So have a look at that one. Try and decide what's actually inside the function, what's not inside the function. And Lucy, yeah, looks good. Just label the you didn't label the 2 there. And Danny, I think you've got your asymptote's not there. And the 3 there should be a 5, I believe. One more from Jake. Jake, yeah, good again, but you haven't labelled your asymptotes. And I think you got 3, so something else is wrong there as well. Just wondering what. Yeah, I feel like you've not moved it up enough there. So we had it on -2. It got flipped back up. It was at 0, moving it up 5. The minimum should definitely be at 5. Yeah, so a couple of bits there. Just have a check through those and make sure you're happy with Y. Right, let's do the second one. So for this one, interestingly enough, so we've got neither of these bits are actually inside the function again. So we could still argue we should use bidmass. But this time the 5 is kind of with the f of x, and then the modulus is outside everything. So it's as if we didn't have modulus, we just drew this graph, and then we stuck modulus on the outside. So in this case, we need to add the 5 first, and then do the modulus. The reason we're not following bidmass is because we're not applying the modulus directly to f of x. We're applying it to the f of x and the 5, so we need to have done the 5 first before we apply the modulus. So we're going to move it up by 5. I'm just going to redraw the original quickly. That was -2. So -2 moving up 5 is going to go up to a modulus, up to an asymptote at 5. The 1 point is going to be -1, 6. Sorry, that's not going to be 5, is it? It's going to be 3. So we've got that. And now we need to do a modulus over all of this thing, which means I need some more space. And this one's not gonna. There's not gonna be much difference for this one because we've got to use the modulus on it. Although you'll notice not much of it is negative anyway. So if you draw that again, I mean, this bit here would go down, kind of infinitely down. So that's going to need to come back up. So we're going to have a bit coming up there, a bit coming up here, and then back to our asymptote. So the asymptote there is at 3. This point is still -1/6. But we now also have this bit ticking back up. So that's slightly harder to draw, that one. Just going to see what you guys did for this one. Jake, very good. Yep, like it. Danny, very good. Brilliant. Whose was that? That's also very good. That was Lucy. Excellent. Nula. Not quite right. Check it through again. Something. I think you're doing the inside modulus maybe, because check this modulus is outside the function in both cases. If it was inside, it'd be with the x. Harry, very good. Louis, can I do it without rotating? Yep, Louis, very good. George, yeah, nice, cool. All right, well done, everyone who tried those ones. Right, maybe do one more set of these. So we'll start with the original function. Yeah, we'll start with the cubic. There we go. So there's our cubic. That's f of x. Can you guys try one? We'll have that's quite a tricky one. and then that one. We'll just do those two. So can you guys again try and sketch those two? You have 5 minutes to do it. Send me photos as well. Cool. And Callum and Ollie, yeah, I've clicked you guys on the register, so that's all sorted. All right, yeah. So 5 minutes, guys. Try and get both of these sketched, and then put them in the Microsoft Teams chat. So timer starts now. Cool. All right, guys. Have I got any answers yet? No. All right, you got another minute while you send me photos. I would like to see everybody send one. So I'll give you a couple more minutes until every single one of you has sent me some kind of sketch. Cool. I think that's most of you. I tried to wait until at least most of the classes replied. So we'll go through these, and then I'll have a quick look through your answers. See if there's any big issues to address or anything. Okay, so these are a bit more difficult. So first one, if you ever look at it and you think, I don't know how to do this, break it down into steps. So just make a list. What are the transformations? So in the first one here, we've got a minus sign out the front. So that's going to be a reflection that affects all the y coordinates. So we can reflect y in x axis. We've got modulus over the whole thing. So we've got a modulus of y. And we've also got a modulus of x in there as well. Now, the order of the modulus of x and the rest doesn't matter because x and y don't affect each other. So I'm going to start numbering these. I'm going to do the modulus of x first because then it's one less thing to worry about. We've got to be careful about the order here though. So we've got brackets and we've got a multiplication. So we need to do the brackets first, followed by the multiplication because of BIDMAS. So brackets first, which is the modulus, followed by multiplying it by -1. So that's my order. You could do the modulus of x anywhere in there if you wanted to, but I think this is going to make a bit more sense. So, and again, you can draw it in 3 separate diagrams. So I'm going to do modulus of x first. So remember, modulus of x is going to get rid of any negative x values and then reflect all the positive x values. So we're going to get this with 3, 4, and minus 3, 4. So that's the modulus of x bit taken care of. The next step is to do modulus of y. Okay. So that's going to reflect up any negative y values. So that's going to be these 2 bits coming up here. These points are still going to be the same. And the last bit is to reflect y in the x-axis. So the whole thing is going to flip underneath. So our sketch for this one should look like this is look like that, which is a bit weird. So it's -3, -4, and 3, -4. So that is what you should have for this one. All right, let's have a look through your answers. Let's see what we get. Right, so Lucy, very good. All I'd say, Lucy, is that the end bits are a bit too curved on yours. They should be straight lines. If you look up here, they're not very curved. This line isn't that curved. So these shouldn't be, but yours curves it in a bit. So be careful that you've got a bit too Batman on it, is what I'd say there. But you got the right ideas. All the transformations are correct there. Louis, Q. Ooh, what have we done? So. I think you've got the wrong reflection, and I think you started with that, Louis. So have another look at this one. Make sure that you're happy with why it's done. The order I think you've got wrong here. So the modulus of x we could have done last if you wanted to. It wouldn't actually have changed anything. So modulus of y next because it's multiplication multiplied by -1. So m next. Remember, modulus of y reflects all the negative y's. Modulus of x reflects only the positive x values in the y-axis. So careful on your definitions of those ones. George, very good. Yours is going a bit Batman-y as well, though. You've got that extra bit curve in, so be careful with that. They could be picky. They could be picky. That's very good. Whose was that one? Elliot, yeah, smashed it. Really good. Nula, you've... Oh, what have we got wrong here? Check for your modulus definitions again. You're close with it, but not quite there. Who else we got? Scott. Scott looks good. You just need to do the you've done the first step, but you've got to get the next couple bits done as well. Chloe, you're on the next one, so I'll leave that for now. Oh, Harry. Very good. Yep, nice. Jay. Yeah, very good. You got a little bit too much curvature, I'd say, in the outward bits. Got Batman logo again. Billy. Same again. Yeah, you guys are all loving the Batman old school logo. So just be careful that those bits shouldn't really. I guess a bit of curve is okay, but they shouldn't be curving as much of you guys as have introduced. Guy, yeah, that's a really good sketch. What else we got? Is that everybody? Yeah. Danny, good, yeah. And Scott, you got the opposite problem. Yours curving the other way. So just be careful with your curvature in these. Right, nice. So hard question. You all at least got somewhere with this one, so that's good. Just check over your definitions of moduluses and your orders. It's really important just to remember what the full definition of modulus of x, delete the negative x's, reflect the positive x's in the y-axis. Modulus of y, delete the negative y's, will reflect the negative y's in the x-axis, and then delete the old negative y's. So make sure you're happy with those. Right, next one doesn't have any moduluses in it, so that's slightly easier. So again, let's make a list of our transformations. So we have a y stretch times 2. We've got a y translation plus 3. We've got an x translation. It does the opposite. Remember, if it says -1, we're going to +1. So again, the x one doesn't matter when we do it. We could do it first, last, or in the middle. Doesn't matter. So I'm going to do the x one first because there's only one x. It's not going to affect anything. The y's we need to be careful with. We need to use BODMAS. So we're going to multiply first, and then we're going to stretch. Sorry, we're going to stretch first, and then we're going to translate. So that'll be my order. So if you think about these points, if we're translating it by 1, drawn that quite big actually, it's a bit smaller. So we translate it by 1 in the x, it's all going to move across. So we're going to get 4, 4, and -1, that's going to go to 0 then. Let's redraw that. So this point's actually now going to be where it crosses. That point's going to be 1, 3, 4, sorry, 4, 4 even. Four, 4, and that's going to be 0, -2, like that. Now we're going to do the y stretch, so we need to stretch those values by 2. I can kind of cheat at this and just double the y values on the graph. So instead of 4, it's going to be 8. Instead of -2, it's now going to be, was it, -4. So that's those done, and then we're going to move it up by 3. So the point -4 is now going to be -1. 0.48 is now going to be 411. And it's not going to cross that 1 anymore, but we can't say where it's going to cross now. So that's it. That's what we should get for this one. I'm just going to quickly go through what you guys have said. Yeah, who was that? That was Danny, brilliant sketch there. Guy, excellent sketch there. Jake. Yeah, good sketch. Remember, you can kind of finish the tails on. You've assumed it still goes through 1, 0. Probably doesn't anymore. We can't tell. We don't know what this point is. Because it's moved up, so it's no longer 0 at the point 1 anymore. Billy, yep, very good. Who's that? Jay. Yeah, good. Bit more curve would be good though. You kind of stopped. You've done the key bits, but you ought to show those ticks at the top and the bottom as well. Whose was that? Harry, yeah, good. Keep the curves going though. There's no reason. There's no reason to just draw that. You want to show that it keeps on going if you could. Chloe. Nice. Wait, hang on. You got 8 there. You got 311 instead of 411. I'm not sure why. Oh no, you got 411. No, that's fine. I just didn't look at the full picture. Yeah, fine, Chloe. Alright. Scott. Oh, you're not done this one yet. Cool. Lucy. Yeah, nice. Neither. Very nice. George, good. Oh, and Louis. Louis, yours isn't quite right here. Yeah, Louis, have a look through this one again. I think you maybe got X and Y's modelled up. Cool. All right, so we're going to move on now. Please have a look over transformations. It does come up in the assignment. It's a very key skill. But what we're going to be doing next is solving modulus equations. Right, and I really like this topic. I don't know why. I just find it quite satisfying. So, I'm going to be solving things such as modulus of x take 5 equals 2. So this is kind of an easy example of the ones. We could be solving ones with multiple modulus equations together. The method is the same for each. So how we solve this is we sketch both functions. And then we decide which bits are original and which are reflections. So I'm going to do that down here and we'll have a quick talk about it. So at the moment you guys probably can't really tell what I mean by that. So we've got y equals x minus 5. So that would just be a straight line going for it minus 5. But then we've got the modulus, so it's going to be reflected back up. And it will go through the point 5 there. And the x value there would be 5 as well. Okay. We're going to draw the other function. The other function is easy. It's just y equals 2. So there we go. So you can see from the graph, we should have 2 solutions. Okay, so which bit of the red graph is original and which is a reflection? So the way I mean original is if there was no modulus signs, which bit would still be where it is? So if there are no modulus signs, this would just be a straight line going through -5. So this bit, let's do it in blue. This bit is original, and this bit is a reflection. Reflection you can't really see there, but I have written what I attempted at the word reflection. So yeah, the original bit is easy because you can just imagine, okay, that solution would still be the same if there were no modulus signs. So for the original bit, I can just pretend the modulus signs aren't there. So I label these solution 1 and solution 2. There's 1, there's 2. For 1, it's just going to be x take 5 equals 2. So we're just forgetting the modulus signs are there. So if I solve that, we get x equals 7. Which looks about right because 7 is after 5 on the x-axis. For the second one though, we've got reflected bit. So that equation, x take 5, doesn't work for the reflected bit. So we need to think of an equation that would work for the reflected bit. So I'd like you guys to have a quick think about this. What is the equation of this line here? Let's see if you can work it out. Looking at the shape it's making, yeah, just see if you can work out what the equation of that line is. Yeah, so I'll give you guys 2 minutes to have a think about that. Please comment either on YouTube or on the Microsoft Teams. So 2 minutes starts now. Right, what have you guys said? So we said 5 minus x equals 2. Yeah, yeah, that's right. Minus x plus 5, x plus 5. Right, Scott, if it was x plus 5, it would need a positive gradient, so it can't be x plus 5. George, yeah, Danny. Yeah, for the most part, people are right there. It's cool, so it's got to have a negative gradient. It looks like it's got the same gradient as the other one, but negative. And instead of going at -5, it's gone for a +5. So in actuality, what we've done is we've changed both of the signs of the terms in the modulus. This becomes a negative and this becomes a positive. So we've got -x plus 5 equals 2. So if we try and solve this now, I'm going to take 5 from each side. So -x is -3. Therefore x equals 3. And does that look right? Yes, it does. Cool, so my solutions are x equals 3 and x equals 7. Right, that was an easy one. It can get harder. So we're going to try another one. So let's have x squared that equals, make it really hard or not? Yes, but start making it harder. Okay, no, maybe we'll do, how long have we got today? We've got a bit of time. I won't make it that difficult yet. We'll do this one equals 2. That might work. Right, I'll do this as an example, and then I'll give you guys one of the harder ones to do. So we want to sketch this this quadratic. So I'm going to cheat and factorize it on the calculator. I don't know if it factorizes, I just kind of made this one up. So quadratic, solve it. Yeah, it doesn't solve perfectly. So if I sketch these, we get one root is 3 plus root 19, which is about 7 point something. And the other root is minus 1 point something. So what was it? Three plus root 19, 3 minus root 19. And the minimum there, because the calculator tells you as well, the minimum there is at minus 3. Right, so I need to draw the modulus version of this. So I'm going to reflect back up. And that's going to cross at 3. All right, it's really important that you work out where this maximum is. Because if we're trying to solve this for equaling 2, let me put 2 in. We solve this for equaling 2, we need to know, is this peak above 2 or below? Because if it was below 2, we'd only have 2 solutions here and here. Because the peak is above 2, we're going to get 4 different solutions. Alright, so the roots there don't actually matter. I don't actually care about any of that, so we can get rid of all those bits. So we've got 4 solutions. Let's go around and number them. So we'll say 1, 2, 3, 4. And we need to have a look at which bits are real and which bits are original and which bits are reflected. So, and I've usefully, I didn't mean to do this, but it worked out quite well. I've used 2 different colours. So the red bits were on my original sketch, and when I reflected it, I then coloured it in blue. So the red bits are original; they would be there no matter what. The blue bits are reflections, so they would be different. So for the for 1 and 4. It's the original curve, so I can just solve x squared minus 6x minus 10 equals 2. So I'm going to take the 2 onto the other side. X squared minus 6x minus 12 is 0. Use my calculator on my quadratic formula. So x squared minus 6x minus 12. If we solve that, we get x equals 3 plus or minus root 21, which is minus 1.583 and 7.582. So those are my 2 solutions. Well, the first 2 solutions. Second 2, 2 and 3, a little bit more difficult. So again, we need to work out what is the equation of this blue curve. So could you guys try and have a think? About what this one's equation might be. Wait, hang on. I have made a mistake there. That 3 should not be a 3, should it? That's the that's where the minimum is. So sorry. If you guys could fix that quickly. I'm just going to type this in again and find the y minimum. So skip that. X min is 3. The y min is, so this is actually 19 for the y. So sorry, just spotted there was a mistake there. So could you guys again have a think? What is the equation of that blue curve? It's quadratic. We need to find out what its equation is. So I'll give you guys again 2 minutes. Have a think. What's the blue equation? Cool, right, we've got one answer. I'm just going to check, see if there's any more over in Teams. No, right, come on guys, have a think. We've got one answer. Just drop your calculator out the window. Oh no, Becky, how did you do that? Is that okay? No, that's awful. Have a look. If it's broken, you might be able to get it fixed. Depends how broken it is. Let me know. Send a photo in Teams if you want. Got it back. Yes, good. All right. Nice. Was that the graphical one? They are quite heavy. I imagine that hit pretty hard. Right, what have you guys gone for? We've got a mix here. I didn't really want you to solve. When I said find the equation, I didn't mean bring the 2 over just yet. I just meant what is the equation of this blue line. So no, okay, oh, that's right then. So right. So yes, I agree with it's got to be a negative x squared. We can see that. It now has a positive intercept, so it's got to be a plus 10 on there as well. And it is going to be a plus 6x. Now the plus 6x might be not misleading, but it can be confusing because you think, hang on, if it's plus 6x, surely the minimum point should be negative. But because of the negative out the front, they cancel out, and that's why. So basically, again, we've changed the sign of everything inside the modulus. So you can use that as a rule if you like. I didn't want to just tell you guys it as a rule. But yeah, you can just, when you're solving for the modulus part, change the sign of everything inside the modulus bracket. So we can set that equal to 2. take 2 from each side, minus x squared plus 6x plus 8 equals 0. Get your calculator out, type it in. So minus x plus 6 plus 8. Solve that, we get x equals 3 plus or minus root 17. Which is 7.12 and minus 1.12, which looks about right on the graph. These are, if you look, these answers here should be between these answers here, and they're just inside that range. Cool, very good, guys. Lots of you rushed ahead a bit there, but that's fine. Okay, cool. Let's crank it up a notch. Let's go one worse. I'm just going to change that to, don't copy it down yet. Okay, mod x plus 5 equals mod of 2x plus 7. Okay, what I'd like you guys to do, first of all, could you sketch it? So I'm going to give you 3 minutes just for the sketch. If you think your sketch is good, you're welcome to go ahead and solve it. 3 minutes, try the sketch, send me a photo onto Teams. Right, so it looks like my choice of question was a bit rubbish there. Sorry, guys. I might change this one in a sec. So yeah, just for the sketch then, x plus 5 would look like that. 2x plus, yeah, this is a bad idea. 2x plus 7 is going to look like that, a bit steeper. So they don't cross, so that was a rubbish example there. Cool, good sketch though. Let's try another one. I'll try and see if I can fix something a bit better. Right, let's go for mod of right. If you guys could sketch and try this one, I'll give you 5 minutes to do that. Send me pictures of your solutions. So 5 minutes. Can you guys solve this one? Right. Yeah, interesting one. This one. It's not the most difficult because it looks like it's just the original parts of both. But so we're going to try and sketch these on the same axes. So x squared minus 4x plus 5. If quickly, I think this one might factorize. No, it doesn't. No. No, I've chosen one with no roots. That was really good, wasn't it? Okay, so that's going to cross at x equals 2, y equals 1. So this is a graph here. So the modulus doesn't even affect this one. I've got to stop making it rubbish questions. Then we've got 3x plus 1. So that's a steep line crossing at 1. So that's going to go through there. So there are at least going to be 2 solutions. What we need to think about though is, does it cross anywhere here? So if we look at this, I don't think it's going to, because the quadratic crosses at 5. This one crosses at 1. It is a steep line, but I don't think it's going to get up to that point. So if we worked out when the line got to 5, say 3x plus 1, minus 4 over 3, it will get there. See, I don't think it's going to get anywhere near. Okay, so it looks like we've just got 2 solutions. So you could just solve this as normal. I won't go through that because I want to get onto one that's slightly harder, but you can check your solutions for this one easily on the calculator. Right. It'd be nice to do something a bit more difficult, but okay, let's try one more. You guys see that? Okay, I might make that one a little bit clearer. Try this one. Bit harder. Be careful with this one. Yeah, I'll give you 4 minutes for this, and this is probably the last one we do today. So 4 minutes, give this a go. Cool. Right, I haven't had any answers for this one yet, but because we've only got 10 minutes left, I would like to start going through it now. So we're going to draw both. They're both different types of moduluses. So we'll draw the one on the left first. So this one crosses at 1 and minus 11. And it's going to get reflected up there. And we know the height it gets reflected back up to is going to be minus 36. So it's going to turn into 36. And it crosses at 11. So it's a little bit scale. I might make the scale a bit better there. There we go. So that could be 36. That can be 11. That's slightly better. For the other one then, we'll draw the original. So we'll solve the original quadratic. And we get a value of 2. This actually turned out better than I thought. 2 and minus 5. So the old quadratic would have, I'm not going to draw it on because it's going to get messy otherwise. It would have gone down here, back up here. Now, because we've got this type of modulus, it's inside the function, it's with the x's. We need to delete all the negative x stuff, and we're just going to keep this positive bit and reflect it over. So I'm going to draw in the positive bit in red, because that was my colour for non-reflection. So that goes down to minus 10. And then we're going to reflect it. It's going to be the same thing going back up again through 2. Cool. All right. As for whether these two will meet again, that's an interesting one. We need to work out, will these two bits here ever meet? And will these two bits here ever meet? And this is quite hard to do. So at the moment, again, if you've got a graphical calculator, it's very easy to do. If you don't have a graphical calculator, we need to work out whether this one, which is currently above this one, because it goes through before, it starts off above, will this one ever go below this one? And will this one ever go below this one? So I'm thinking, because we got, I reckon one of these is going to meet. So let's try just putting in a few x values into our equations, because if you don't have a graphical calculator, that's the only way that we can be able to do this. Yeah, I mean, it looks like this one here is slightly steeper. It's got a 10, so it looks like this is going to curve up faster. But it also means this is going to curve up faster. So yeah, they might meet again. All right, so we're going to try a couple of values. So if I go back to the original calculator, if I put in maybe x is 20, so I'm going to put 20 into each one of these. So for the first one, I get 589. For the second one, get 450. So for 20, this one is still above this one, and I think that pattern's going to stay the whole way around. For the other one, we need to try putting, and this is going to be a bit harder because we've got one original bit and one reflected bit. So I'm going to put maybe minus 20, maybe bigger number, maybe minus 50 because we are going quite far, into this one, minus 50 into this one, and see which one comes out on top. I've got a suspicion it might not be the one that currently is. So minus 50 all squared, it's going to be 50 squared. Take away 50 times 10, take away 11, gives me 1989 for the first one. For the second one, so minus 50 modulus squared is going to be 50 squared, plus 3 times 50, take 10. Yeah, so, oh, actually, no, this one's still on top. So I don't think these are going to cross again. I'm going to double check on my graphical calculator, which is here. So the calculator is quite useful for these. It will let you sketch them and see how many solutions you have straight away. So if I go to graph, it's going to delete all these. Right, so we're doing modulus, so we're going to type in option, numerical, abs, x squared plus 10x minus 11. That's one of them. The other one, we're going to need lots of those, lots of abs, so abs, x, square root, plus 3 lots of abs, x, minus 10. Cool, and we're drawing those. So you can kind of see again, yeah, let's zoom out a bit. So if I view window, let's go to what, minus 50, 50. The y values, we don't need to go any further down than minus 10, so I'm going to go to minus 10 there, and max y values, let's make it quite big, maybe 50 there. So there we get a nice kind of view of what's going on. Our sketch looks pretty good. We can see, yeah, there's one intersection there. Is there another intersection? We're looking to try and see, does the are they converging or diverging? So keep scrolling up. Might be here sometime. It looks like they're not going to converge, but if we maybe go higher with our y values, if we go up to 2000, we can see that the blue does stay on top and the red does stay on top of the other part. So it looks like they only cross once, which is going to be the reflected parts of both, which does make this a little bit harder to solve. Alright, I don't know if any of you guys have done any answers. I've got a couple. Cool. Alright, so we need to solve the reflected parts of both of these. Oh god, I didn't realise it was almost half past already. So, there's no real bits to solve here at all. We're just looking for this solution here. So, which is both reflected bits. So if we get rid of all this. And the rule we can use, remember, change all the signs of all the things in the modulus. We've got minus x squared, minus 10x, plus 11 equals x squared. If I make that negative, it's still going to be x squared, minus 3x, minus 10. So that's what I need to solve. So if I rearrange this, we're going to get 2x squared plus 7x minus 21 equals 0. Onto the calculator to solve that. And we get x equals, no, it has given us two solutions. Let me just check I've done that right. Minus x squared minus 10x plus 11 x squared minus 3x minus 10. Yeah, looks right to me. 2x squared 7 that's 21. Yeah. So it gives me one solution at 1.9327 and one solution at minus 5.43. I'm just going to check this on the calculator. I don't really trust that because I think we should just get one solution. Let's see what you guys have done while this loads. You did the same thing I did. 2, 7, 21. Yeah, I'm going to check those on the calculator quickly. So if I sketch those again, I'm going to zoom right out this time. What should we go to? There we go. Gsolve, intersect. And there is only one. I don't know why solving this has given me 2. But yeah, minus 5.43 is the only solution. So that one shouldn't be there. Cool. What have I done? Have I not reflected it in the y-axis? Yeah, I did reflect it in the y-axis. What are you guys saying real quick? Jake's saying minus x squared. I know this would be a minus x, but when you square a minus x, it becomes x squared. So, yeah. I was wondering why. Would that change things? You would get rid of the x squared, so you'd get 7x is 21, 21. Yeah, no, that doesn't make sense to me either. I think it's just because I've chosen a difficult question, like without the sketch. It's weird the calculus. It was weird that I found 2 solutions. What's wrong with the answer? Now this answer's fine. I'm just wondering why we got a second solution. It's because the x squareds didn't cancel. They shouldn't. So I think it's because I've chosen to do this modulus with this modulus. The maths is a bit weird there. Maybe we've got a complex root instead. I'm not sure, but that one's right, and we can check that with the sketch, which we did anyway. So we're very confident this is correct. Yeah, that one we just have to say no solution here because we didn't see it in our sketch either. Right, I think we'll do a couple more of these as a starter on Friday before we move on to the last bit of this topic. Can I just a quick reminder to you all, can you make sure the Moodle assignments and skills checks are done by the weekend? Can you make sure the stats mechanics test is done and emailed to me by the weekend? And I think I'm still waiting on one of you to do the retest. One of you received it today, I think, so I will get those done over the weekend as well. But make sure I get any outstanding work. And the next assignment should be done for Friday, so if you guys can get that one done as well. We're going to have a big weekend of marking ahead of me, but I'd like to make sure all that's kind of done for then, and then we're kind of, all the A-level, all the first year stuff is kind of done, finished. And if you guys want to go through and revise it, you can. Alright, thanks guys. Sorry we ran over a bit today, but I wanted to finish this. If you need any help with anything in the meantime, let me know. Otherwise, I'll see you guys on Friday for a little bit more of this, and then on to the next topic. Yeah, no, that's fine. Yeah, the modulus would make it positive. Sorry, squaring it will make it positive anyway. So, all right, cheers.